Hello everyone, I'm Matěj and I'll be talking you about connecting MIDI to SwiftUI. I've been interested in generative design and I have some friends who are VJs and are live coding from time to time, and I've experimented with these devices and I want to show you my experiments too. So, firstly, we'll take a quick look at MIDI for those who are not familiar with the technology. Secondly, I'll introduce you to a core MIDI framework by Apple. Then we'll look at how you can use core MIDI with Combine and SwiftUI. And last, I'll show you some demos where we can see how it can be used to improve or to prototype human-computer interaction. So let's look at MIDI, what it really is. It is a quite broad standard for musical digital instruments. It was created quite a long time ago, in the 80s, and it hasn't changed much since then. As I already said, the standard is quite wide. It contains the hardware specifications, how the cables that these devices can be connected to each other, the file type, and which can be used to store all these messages and events from the controllers, and a protocol, which is the most interesting things to us. Maybe it's a bit counterintuitive, but it's not an audio signal. You can think of it as notes, because these events, these messages, can later be synthesized into audio signal. So maybe it's similar to when you play an instrument, you have a note and then these are the MIDI, and then you can later convert them to proper audio signal, proper music. So how these messages look? They are quite small. It's only 3 bytes of data. Every message is really simple. That contains 4 pieces of information. The first part is the status, which is some event, and I'll show you. This event can be a note on or note off event, or a control change. Channel is something different. It's used to identify the messages, because if you have a larger network of those devices, you need to filter out the inputs based on from where it's coming from. So that's the thing that the channel is used mainly, but we won't need it in this presentation because we have only few devices. The data one is used to identify the input. So it changes if I use another button or another control, another knob. And the data 2 byte is mainly used for the value, which can be a pressure or velocity or the value of the knob. So let's move on to core MIDI framework. Core MIDI is a simple API that helps us with communication with MIDI devices. It's supported since the first OS X, and it's even supported on iOS for 10 years. So as you can see, it's quite old. It's there a long time before Swift. And another great thing about it is that it doesn't need any special permissions. the data is not private and you need them really fast. So basically it works anywhere. And by anywhere, I mean it works in both Swift playgrounds and Xcode playgrounds on iPad and Mac. And it even works in SwiftUI previews, which really helped me during the development of this presentation. The core MIDI provide us a MIDI client. You as a user can open port and connect some devices to it. The client can have more ports, and they are both input ports and output ports. There are some devices that can receive MIDI messages and that can be used, for example, if you have some drums and you need to send the beats per minute or some rhythm, then some other devices can receive those values and handle them. But the thing that interests us today is mainly the input and visualization of this input. So we will be working mainly with the sources and we'll open an input port. Since core MIDI was created long time before Swift, it's written mainly in pure C. That means the data that we receive is in C structures. It's automatically converted. The headers are automatically converted to Swift, and as you can see, it doesn't help us much. So I've worked with it, improved this. I tried to improve this and created a small library. So let's look how to use core MIDI in SwiftUI and with Combine. The small library I created is called Combine MIDI. It just provides us a simple type-safe description of the messages, and it even has all the status is defined. If you want to have a look at how everything is defined in it, just go to GitHub. I open sources today. And it also provides a MIDI publisher, which connects to the client and listens to all the messages. I won't go into the detail. If you are interested, just look at the implementation. But it's pretty simple, but still, I just want to show you some more practical examples. So far, in the previous slides, we've been using the MIDI observable object from the library that just publishes the last value from the client. It basically takes all the values and it sends them to the main thread to display in user interface. That was enough so far, but we need to, if we want to do something more complicated, we will build some pipelines that helps us to do it. So I'll show you some motivational example. I have a simple shape. It's a regular polygon, and only two values are used to draw this shape. And it's number of edges and number of rounds that we go around to draw this. So if I change the number of edges, you can see it's drawing different regular convex polygon. If I increase the number of rounds, it draws a regular star. So let's look at how the combine was connected to this view. I've defined a state which is made only from two floats, and I've used this, used the MIDI client publisher and some operators to connect it and update the state. This is basically the thing we'll see in all the examples that I'll be showing you later. So how do the operators look like? First, if you want to filter out these two values, we need to only take the control change status. Then we will use a scan, which is similar to reduce, but the difference between reduce and scan is that reduce only returns the value when the publisher finishes. But our stream of values can run indefinitely. That's why we are using scan, which returns the partial result every time a new message is received. So we just set up an initial state, and then when a new message is received, calculate a new state. That means when we receive the data from the controller, the first controller, we'll just update the value of edges. And when we receive the value from the second knob, then we update the number of rounds and return the new state. And that's basically everything we'll need to create new states and manipulate them. If you want to look at how these pads can be used to connect these, to create a state, that these pads are sending a value of the strength, how strong did I touch them. So the state that I'm using here is a two-dimensional array. And when I touch them, you can see that if I touch them strongly, the value and the opacity is lower. So we'll use the same concept. We'll use scan. And then we calculate the new result. We'll just need from the data 1 byte, we just calculate the indices and assign to the proper index in this two-dimensional array. And then we'll just calculate the value of the opacity, which is when the note on message status is sent, we just calculate the opacity, otherwise we just assign a 0. And then return the new result. So that's how we build our state for this view. What I want to show you now is that this state can be manipulated to create some nice user interface. So we have 8 floats, which can be converted to a gradient. Each color has a hue, saturation, brightness, and opacity. These are the 4 knobs. And the second color is the second row of knobs. So we've taken the state from the previous example and converted it to gradient. And here the human-computer interaction can be improved by these hardware knobs, because mostly we are using just touch screens, but there's much bigger pleasure just touching the knobs and buttons and have physical feel to them. So let's look at how fast we can create a pretty nice gradient, which would take very long when you've been just mingling with some numbers. Okay. It took only a few seconds to create a gradient I like, and if you just used a mouse or keyboard, it would take much longer time. So when you are doing some real-time visualizations or real-time art, it can really help to have this physical button, because like mouse has only two axes, just X and Y, and these can provide much more variable input. Next example is this controller that I didn't use previously. It sends X, Y, Z axis. The Z is how strong and how large, connected to how strong and large the circle looks. So the state looks like this. So I've made a touchpad from it, basically. What I want to show you in the code now is that the publishers can be created a bit differently. You don't need a single pipeline every time. You can create the X-publish by filtering and calculating the value for it. And you can do the same thing for the remaining dimensions. And then, in the end, just zip them together, just combine them into a single value. I can use zip in this case because this controller is sending all these three messages every time some of them changes, so I know it's consistent. Otherwise, I would need to use combine latest. The last example I want to show you is using time in our sketches. So I want to plot the value of the control knobs over time. I have array of the last 100 values. But as you can see, when I receive messages only when a new value is received. That means when I'm not doing anything, it's not moving anywhere. And I want to work with the time, so this time in the code I need to start with something else. So this is the result we want to achieve. If I'm not doing anything, basically the graph is not drawing anything. Even when I have this pad connected to it, I can draw a nice sine wave, and the sine wave is as nice as I can draw a circle, so hopefully it works. So this time we need to start with something different that we started in the previous slides. This time we'll start with the timer publisher that emits a new value 60 times per second. So we have the time variable in here. We need to auto-connect it. So it starts when the first MIDI message is received, because before then we don't need to do any work. And we need to combine the time with the values we receive from the MIDI controllers. And we just filter the control channel messages and only the values from it. And we need to receive it on the same run loop as the timer is running on. Now, more messages can be received over the interval, and we need to remove the duplicates because we don't want any glitches. So if more messages are received during the interval, we just remove them. Our state in this case is just an array of 100 messages. And when a new message is received, we just take the previous result, remove the oldest value, and append the new message. It's not the most effective way we could do this, but for the sake of this example, it works pretty well. And that's basically all I wanted to show you. I hope it inspired you a bit. And we've leveraged something pretty old, something that predates Swift, to learn something new. I think those experiments are great for learning. You just don't need to have some goal. I figured out that for me it works that I just try a new thing, search through the documentation and find something new, and like this can be used to create something original. At least I hope it can be. We've experimented with the MIDI, and we've had some ideas with the human-computer interaction. I've shown you some gradient that when you develop a photo editing application that can be used to filter and to control filters, so it can increase a photographer productivity, for example, or video editing productivity. And hopefully we've explored some reactive programming concepts on the way, mainly the operators in Combine. So thank you for watching, and I hope you enjoy the rest of the conference.